In this last video for the law of sines, we're not going to look at the law of sines, but we are going to be looking at triangles that we've been working with, specifically this idea of an oblique triangle, which says that our takeaway from this oblique triangle is there's no right angle. And we're going to be looking at finding the area of such a triangle. If you think back on your previous, I know you try to purge this information, but if you think back in your math studies over the year, you've looked at something that the area of a triangle is 1/2 the base times the height. And when you've used this formula to find the area of a triangle, the base is pretty self-explanatory, the base of the triangle. So here that would be the base. And then the height of the triangle, this is specifically, if we had a right triangle, this height here is formed making a 90-degree angle with the base. So the area would be 1/2 this length times this length. However, in the example we're going to be considering now and using the formula we're going to take a look at, we can't use this formula because we don't have a right triangle. So we don't have a height that we're going to be able to use. If we take a look at this picture here first, and then I'll go back up here to take a look at what those words are saying. We have a triangle, an oblique triangle, ABC, but there's no right angle. So in order to use the formula from here, area is 1/2. C, this would be our base, but now our height is going to be this line here. It's formed by dropping a perpendicular line to our base. We are not going to be given this height here. We're going to know the side A, the side B, and the side C, not H. Could we figure out the length of this side H? Absolutely, we could. That's a geometry course. That's not what we're going to be doing here. What we're going to be doing is finding the area of this triangle just using the lengths A, B, C, and not going ahead and finding any height here. So we're not using this. I'm going to cross that out. We instead are going to be using these formulas here. And what these formulas here say, and these words say it out, but you can read the words yourself, so I'll just talk about them, that the area of a triangle, we're going to have the 1/2 again in each of these, but what the 1/2 is going to be multiplied by are the lengths of two sides. In this case, it's going to be side B and side C, and now that's going to be multiplied by the sine of angle A. So notice, here's side B, here's side C. Angle A is the angle in between A and C. Another version, same formula, and they all would give us the same answer, that the area is 1/2. Now we're looking at side A and B, so we're looking at side A here and side B, and we can see that's going to be multiplied by the sine of the angle that's included between A and B, which is C. Last version, 1/2. This time we're going to be looking at side A and side C, and we're going to be multiplying by the sine of angle B, which is the angle in between side A and B. So this formula says if you have two lengths of the sides of a triangle and you know the angle in between those two sides, you're going to be able to use this formula to find the area. So let's take a look at an example as usual. Here we want to find the area of a triangle having sides of length 8 and 12 and an included angle of 135 degrees. So we haven't named these. We could, if you wanted to. I could call, well, let's go back here. And no, maybe not. Maybe we don't want to mess with that if it's not accurate. So we can call this A. We can call this side A. We can call this side B, and then this would be uppercase C. This would be the angle C here. It doesn't really matter how we label these, but it's two sides And this angle here, very important, is included in between them. So looking at our formula, it's going to be A is equal to 1/2 A times B times the sine of C. So we have area is 1/2 of our 8 times our 12 times the sine of 135 degrees. So plugging in for our formula, or 1/2 the length of two sides times the sine of the included angle, if you want to skip writing that. And now when we do this calculation, let me change this to approximately equal to, because the sine of 135 is going to be a decimal number. This gives us 34, and we're asked to round to the nearest square meter. So this rounds to 34.0, and now this is going to be meters squared. I'm going to put the measure in there because this is meters, so meters times meters is meters squared, and that would be our answer.